So let's take a look at the Centipede high score save circuit. Now, what you will see here is there's not many chips involved, but we need to first, before we touch anything, validate a few things. We need to validate input voltages at plus 15V and negative 15V. Now this is nice, they have test points on the Centipede PCB to do this. What happens is these guys come together, and with the 555 circuit at A11, on pin 3 of the A11, 30 negative volts is created and fed to pin 14 on the EAROM chip. So that's how the voltages work. And before you look at any chip in the circuit, you need to first verify those voltages. Plus 15, minus 15, and then test the 30. If you don't have plus 15, replace the plus 15 voltage regulator. If you don't have negative 15, replace the negative 15 voltage regulator. If you have both of those, but your negative 30 is not close, like negative 28, 27 is fine, then replace the 555 at A11. Before you check those things, before you do anything else, you need to check and verify those things, because without the negative 30 or close to negative 30 on pin 14 of E5, the EAROM chip, high scores will not work. So, we're going to look at this Centipede high score circuit. Put in test mode, you'll notice we have FF there. That doesn't mean that it's bad, because if you have just basically, when you plug it in, if it doesn't have the correct data on it, it's corrupt, it will often say that. So you just hit fire and press 1, and then go ahead, start your game, play a game, turn it off, turn it back on, see if it still says FF, or if it has something on the bottom that tells you number of plays. Well, I already did that. It doesn't. So it's time to troubleshoot this. Now, from what we saw in the schematics, we're going to test the voltage points, because you have to have, first of all, you have to have this on a real Centipede power supply, because a normal jam switcher won't have the power that it needs. Which is, I believe, plus and minus 22 volts from the switcher. So, let's do that. So the first thing we do is we're going to put in voltometer mode. You can see this. And we'll test it. Maybe I'll put that, I don't know if that helps or not. I'm going to do that. Maybe it helps, maybe it doesn't. So I'm going to put this in ground here and test. Now we want to test the 15 volt, the 22 volt. We've got 24 negative, that's right, because we're testing negative 24, plus 22, which is 23, that's fine. Negative 15, which is controlled by this voltage regulator here. We have that. And then positive 15, which is controlled by this voltage regulator here. We have that. Okay, so all the voltage regulators look fine. Now, we need a plus 28 on pin, I think it's the third from the back here, which is pin, what is that? 11, 12, 14. And we only have 14 volts negative, which is not correct. We need 28. So let's figure out what's going on. This is the main component here, this 555 at A11. So we're just going to switch that out, because that thing goes bad all the time. Let's see if that has any effect. So we replace the 555, and now you see at pin 14, we have about negative 26.8. That's close enough. That's perfectly fine. So that's one thing that this thing often goes bad, and there's no even point in even looking at this chip until you verified these guys are working. and that's working. Because if you don't have the voltages, this chip's not going to work. So if you like that video, please consider becoming a Patreon sponsor at www.patreon.com/arcades.